So we use JSON web tokens. This is a protocol that you can find out there on the web. It wasn't invented in Atlassian. And each token is a string. You can send it along with the request, and it helps to verify the identity of the sender and that the request wasn't tampered with and that it wasn't replayed at a later date. So you can just include it as a parameter on an HTTP request. You can also put it in a header. We've chosen to allow both. So for example, this could be an iframe URL, and on the end, there's a JWT parameter, and we read that in Connect. It could also be there as an authorization HTTP header. Now, this JSON web token is a string, but what does it look like? Well, it's structured. It has a header, and then some claims in the middle, and then a signature at the end. Now, the header and the claims are JSON, so this should be very easy for everybody here to parse, both in their heads and in their code. The header's not very interesting. It's very brief. It just says the type of this message is it's JWT, and it uses a particular cryptographic algorithm. The claims in the middle is where the real meat is. This is the interesting stuff. So it says, oh, this is the issuer, and it expires at this time. Don't consider it valid after this time. It also has a bunch of other standard claims that are part of the JWT protocol, and the JWT protocol allows you to add custom claims, and we've done that. We've added one particular custom claim, which I'll come to in a minute. At the end, there's a cryptographic signature. This is computed over the preceding two parts. It's very hard to fake. You'd have to actually know someone's private key or their shared secret. So if the signature matches the rest of the token, then you know it's good. It's extremely hard to fake. Then in the end, the whole thing is base 64 encoded, so you get jumble of letters and numbers, and then a dot, jumble of letters and numbers, dot, signature. So it's got three parts. So let's bring it back to the analogy. So you remember in the real letter, you got the sender claim. You have the handwriting, which is like a signature, very hard to fake. You've got the tamper evidence on the right-hand side. You can see someone's torn it open. And you've got the postmark. Well, in JWT, the sender is the issuer claim. Very simple, just plain text, says this is who I am. The physical signature on the letter is like the cryptographic signature in JWT. Very hard to fake. So if you change the content of the JWT token, the signature looks wrong. Another thing that makes things look wrong if they've been tampered with is we have a custom claim called the query hash claim, which is a hash of the parts of the URL we do not expect to change due to routing rules. So if somebody adds, removes, or edits a query parameter, for example, then the query hash will look wrong. And if you manipulate the query hash without being the person who genuinely is issuing this token, then the signature will look wrong.